Hi, people. Welcome again. We are starting another episode of ChatLoopBackOff. This is the episode 75. We are going to dive into the code behind Cloud Native. I am Sergio Mendez. I will be your host today. So let me tell you that every week we bring a new set of presenters to showcase how to work with Cloud Native technologies. They will be building things, they will be breaking things, and they will be answering your questions. So, so in today's sessions, I'm stoked to introduce Shivay Lamba, who will be exploring Trulens in this chat loopback episode 75. This is an official live streaming of CNCF, such as is subject to CNCF Code of Conduct. Please do not add anything to the chat or questions that could be in violation of that Code of Conduct. So you can use the chat to add your questions, and we are going to read it after the presentation. So basically, please be respectful of all your fellows participants and presenters. With that, I will hand it over to Shivay Lambda to kick off today's presentation. So welcome to Shivay. And let me see because I lose it. Okay. And just let me your screen. Okay. So welcome to Shivai. It's your time.
Yeah, thank you so much, Sergio. And I hope everyone who is tuning in live is excited as much as I'm. It's my third time on ChatLoop Backoff. So my last ChatLoop Backoff was probably with Kserve. And again, I come from a machine learning background myself. I've contributed quite extensively to CNC projects like Kubeflow. I've also been one of the release fellows for Kubeflow and part of the Google Center of Code program for Kubeflow. So super excited to be back again and exploring another project. And if I'm not mistaken, this is probably supposed to be like the first chat loop back off for the year. So I'm excited to kick this off and also looking forward for the future iterations of chat loop back off. And for those folks who are not aware, the idea is that we explore a new CNCF projects together. It's my first time actually going to be exploring this particular project, and given the fact that the entire CNCF landscape is ever increasing, there are new projects coming up. Probably every single month, that it can be a bit tricky or challenging to go through a new project together. So this is not just like, hey, what exactly this project does, but trying to explore it as someone who is brand new to that particular concept or to that particular project would do. So with that in mind, we will get started. So today's CNCF project that we are looking at is Trulens. So let me start by sharing my screen. Okay, so uh, just let me know if everyone is able to see my screen right now. If everyone who is there in the chat section, or Sergio, if you could also quickly just let us know if you're able to see the screen. Just want to confirm. Just want to double check if everyone is able to watch my screen.
Yes, I can see your screen.
All right, perfect. Okay, perfect. So yeah, let's explore what TrueLens has to offer. So the moment you land on the website, it says TrueLens is evaluation and tracing your AI agents, and I guess like it is perfectly apt these days because everyone is going crazy with agents. So like you talk about OpenClaw getting the founder of OpenClaw getting acquired by OpenAI, and the OpenClaw repository, like it just took off in terms of GitHub stars. In a matter of like a few days, it overtook Kubernetes, which is always like one of the most popular open source projects out there, and it also took past like Next.js. So having something that can trace and evaluate agentic AI is probably very relevant for today, because more and more companies are actually adopting agentic AI. And if you talk about even Kubernetes and the CNCF, we have had a lot of discussions, a lot of adoption around States GPT. That is like the quote unquote original agent that could sit as part of your Kubernetes cluster, and you could understand, okay, like what's going well, what's going wrong with your K8s cluster. And then, we have had like K Agent, which is kind of this released by Solo.io, which is an open source project that with which you can orchestrate and run AI agents. But then you can also always run agents with agent frameworks like Llama Index or LangChain inside of Kubernetes, and you can scale that. And you have like KMCP. So like a lot of projects that are starting to prop up. And if you talk about just open telemetry, because this talks about tracing. So of course, at the top, you also see this banner around Trulens is now open telemetry compatible. If you're not already aware, there's this another project called as Open Elemetry, which kind of is an open source project by Traceloop, which is providing you open source observability for LLM or GenAI applications based on open telemetry. So, I mean, there has been some amount of work around this, but what I guess is more unique to Trulens is that apart from tracing these AI agents, it also looks at evaluations. So you evaluate, iterate, and select your best AI agent to Trulens. But yeah, I mean, let's move forward, because I think what also will be unique for people to understand is like, okay, what is the main difference between evaluation and tracing, right? Because these are two words, and I mean, coming from someone who has used projects which kind of sit in a similar realm, I would love to kind of iterate over that as well. But then what I would personally like to see is, because I have not personally used Trulens so far, what I would like to personally see is like how it differentiates as compared to some of these other existing solutions that are out there, open source solutions which are out there for doing evals and tracing. Because like if you talk about evals and tracing, like these are the two big pillars after you have built your agent. So what evals would basically kind of give you an answer is, they will give you an answer of, okay, providing you feedback on whether the responses that you get, um, are those making sense or not. And then tracing is, as we know with open telemetry, that you trace all of your requests and you can understand, okay, what went well, what went wrong. Because your ultimately your AI agent system is not like the standalone system, but rather an agentic system is always going to be part of your existing software system. So similar to how you would trace your typical software applications, you would still apply the same principles. So you still need like spans, you still need traces when you're incorporating AI agents. And it'll be interesting to see like how Trulens does that, because generally you would like create like specific spans, and then you add them as part of your, or you embed them with like the Open Telemetry SDK in that particular language, and then you embed it. So it'll be interesting to see like how Trulens does that. But if you see like the first line which says Trulens is moving from vibe coding to metrics, because yeah, like with vibe coding, one of the most I guess one of the drawbacks of vibe coding is like if you're doing it in a true vibe coding style, you might probably not realize if the responses that you're getting from an LLM model, are they good enough or not. So what we would probably want is, we want to always objectively measure the quality and effectiveness of the AI agent, rather than just like randomly deploying it in the wild. So you are going to look at the execution flow of your agent with the retrieved context, tool calls, plans, so that you could expedite experiment evaluation at scale. So, I mean, for those folks who are not completely aware of how an AI agent works, I think it will be like a good thing to just kind of give a quick overview of what an agent does. So, imagine like this is your AI agent. So an AI agent typically has an LLM as its brain. So when we say, okay, like what exactly is like the brain of an agent, because an agent is supposed to do a task. So generally the LLM would kind of be the brain, which means that all of the decisions are being made by the LLM. But as we know that LLMs are transformer based models, these are generative models which are primarily focused on generating text or images, but they cannot actually make API calls or they cannot call functions. So generally an agent will have something called as tools, and these tools are nothing but like just specific functions that can be called based on a certain action being performed by the agent. So the LLM will decide what action needs to be performed, and then there might be n number of tools, and it will use the most appropriate tool to do that action. So generally you have things like memory to add some level of remembrance, so that your agent can actually remember past conversations and become more personalized. So you have this basic core concept of an AI agent, and then there are different types of agentic systems. So there's like a simple human in the loop agent. There's like a reflective agent. So there are different categories of agents. So what this particular line is saying essentially is that if you talk about every single critical component of an agentic system, so that would have the retrieve context. If you're using like retrieval augmented generation, you'll have tool calls, you'll probably have a plan mode that the agent itself kicks off, uh, and then you want to evaluate each one of those particular things, whether you're using it for AI agents or you're using it for RAG. So those are the core ideas. So that is why I guess we have evaluations at first, which basically tells us about how the LLM is making the specific choices, and this will be based on certain metrics, so such as the groundness, the context relevance, and the coherence. So generally, what groundness essentially means is that our so think of it in this way, because this is a concept that's not like necessarily just for Trulens, but rather, if you talk about LLMs in general, what evaluations or evals basically tell you is the fact, like if you talk about groundedness, is that are the answers claimed supported by the retrieve context. So the idea is that if you talk about a typical RAG pipeline, I think like it's important for people to understand, like those who don't come from a AI background. So a RAG, if talk like just about RAG, generally what happens is that the user asks the question to the LLM. So the user will send a query to the LLM here, and the LLM will generate a response. So the LLM, this is the query, and the LLM generates a response, and this is based on the limited knowledge that the LLM has. But what if an LLM needs to answer a question from an internal database of a company? So of course it won't be able to do that because the LLM has never been trained upon that data. So in a RAG use case, what would happen is the user first asks a question, and this query is initially sent not directly to the LLM, but rather to a vector database which contains the vector data of like the internal data. So then what happens further is that we perform a vector search, and we say that this is the relevant context, which is information not originally obtained by the LLM, but rather it's an internal data source on which the LLM was never trained. So we ask the question, we perform vector search and get the relevant context, and we pass the relevant context plus the query to the LLM. So here, this is where the LLM comes in, and then it generates the response. So whenever we talk about the relevant response, so whenever you talk about retrieved context, which in this conversation, it talks about context relevance, or we are talking about groundedness when it comes to retrieve context in case of like a RAG pipeline. So the idea would be that, okay, are the answers claimed supported by the relevant context that we have gotten after performing our vector search operation? And it kind of more talks about the answerability, like if the context doesn't have enough information, is the model appropriately cautious rather than just hallucinating directly? So I guess like we'll go much deeper into this, because overall in a nutshell, like what evaluations basically do is that they give you the groundwork to ensure that the AI systems are actually giving you accurate responses. They are sticking to the prompts that you've given to them, and they are sticking to the retrieve context that on the basis of which they are supposed to ground their own response and then give it to you, rather than just simply hallucinating altogether. So that is like evals, and evals are a very important part of generative AI. So it's good that Trulens has like native support. So we'll explore how that works out internally when using Trulens. And then we have like iterate. So this talks about leveraging an extensive library of built-in metrics. So I guess like that's probably mostly coming from OpenTelemetry because it has direct support of OpenTelemetry, and then you can compare between different types of LLM apps. And how this works, so this is like a nice diagram. So you build your LLM application with the human and the agentic AI. You connect it to a database for logging your traces and evals. So of course, like we would still need a DB, to be able to collect all of your traces that could be used for now exploring those evaluations, and then we can explore these traces, and evaluation runs across different app versions. So that's great. Like this that one of the key things here is that one of the key reasons why we need to have traces across multiple app versions is the fact because whenever you're doing experimentation inside of computer science, like especially with agents, like you're making a lot of iterative changes, like you're making slight changes to the prompt, or you're making slight changes to maybe some groundness that you want to run, and maybe you're also changing the architecture of the agent. So that way, if you want to find out what version of that agent or what version of that app gives you the best response, then you could manage it. Like rather than having to maintain separate repositories altogether for different agents, you could just have like different app versions. So it's like similar to having and this is like very much central to a core machine learning, where you're doing a lot of experimentations. And generally, if you talk about like standard or typical machine learning, there you're using something like a DVC, which is distributed version control. Not distributed, like it's similar to like Git, but you're doing a version control on the data, you're doing version control on your model weights, and this way you can iterate over which particular version of the app works out best. So here we can see like you're choosing between like the different LLMs, you're choosing between different types of search mechanisms, different types of tool calls, and different versions of the prompt. So that's a good thing, because I guess at least based on my previous experience having worked with some of the other open source tools around this, this level of granularity when it comes to being able to like pick up versions at this level, I've not really seen this much customizability when it comes to like iterating between different versions. So that's pretty interesting. And the next thing that we see is interoperable tracing. So it emits and evaluates OpenTelemetry traces. So that's great. And Trulens provides benchmarked evaluations. So we'll go deeper into that. So you get all of these. I think this is already covered, and you can use it with RAG agents. And I think we are good. So we can probably get started with the documentation, and then we can dive deeper. So let's go to our docs. And again, in the meantime, if anyone does come up with any questions, do let us know. Would love to answer questions, because we are also exploring this project for the first time, as all of you on the stream might also be doing that. So our first look at the docs is to go ahead and install all of these dependencies. So we can also actually get started with the quick start notebook. Let's also just open that up separately. So here, I guess like the installation is mainly just looking at creating a virtual environment with Conda and Python. So do ensure that all of you do have Conda and Python installed. So I'll just go ahead and follow this, and I'll probably give it like Trulens demo, and we'll just go ahead and create this demo. Looks like a good thing is that there is a built-in notebook as well, which we can open up in Google Colab, which we could also try to use. But let's just go ahead and run this, and then I'll activate my virtual environment, and we'll just go ahead and install Trulens. So I think that should be good, and then later on we can start to run it. So that's pretty much it with respect to the installation. And in order to like, I'll also just open up the core concepts and open up all of the relevant. I think these should be the four relevant informations. I guess before we kickstart Trulens, let's also just go into the core concepts. So yeah, I mean, we have already kind of given an idea of what an agent does. So the agent is like essentially the entire component of the application that makes call to the LLMs with the help of tools and maintaining the state via memory. Um, looks okay. So this mostly looks about the different key terminologies that we have when it comes to interacting with agents. So I think we can probably skip over this. We'll probably come across this as we explore this further. Okay, so maybe we kick start it with the Trulens quick start guide, and then we jump into the more in-depth ideas behind like evals and the built-in instrumentation that we have, because those are like the two building blocks of Trulens. But let's also open up this quick start guide. So that's over here in the IPython notebook. So, by the way, like for those people, for those folks who are not aware, Google Colab is a great way to run Python code, or if you're doing some kind of machine learning code and you don't necessarily have like the compute on your local laptop, you can use Google. You can use Google Colab because it gives you free access to a GPU. So here in the runtime, you can choose between different types of runtimes. So it gives you like free access, and it's like fairly nice. Like for open source contributors, you can either use platforms like Kaggle or you can use Google Colab. But the only drawback is that it only stays active while you're connected to the instance. Like, so if you time out or maybe if you restart your laptop, then you lose that particular session. So that's the only drawback. But yeah, I mean, if you don't have a GPU, then I mean, I guess for our example, we won't need a GPU, but there's something to keep in mind. So maybe what we can do is we can actually run this side by side. One of the new features that I like about like some of the built-in, like I use Chrome, that you can open up a new tab in a new view. So what I'll do is I'll just open this up so that we can run it side by side, and I'll just reduce this. But so let's go through this, and as relevant, we'll run the blocks in the quick start guide. So initially, at least based on this quick start guide, we are going to create a retrieval augmented generation application from scratch. We will trace the execution and get feedback on the LLM response. And for evals, we are leveraging the hallucination triad of groundness, context relevance, and answer relevance. So we'll explore more about that, like what each one of them means. But initially, we are going to go ahead and let me actually remove this question mark. We'll go ahead and install all of our dependencies. So here we are installing Trulens. We are looking at a Trulens provider. So what looks like the case is that if you looked at the intro, it actually has support for different type of LLMs. So if I explore, maybe we can probably see the component guides, or perhaps it should be mentioned somewhere where we have access to like different models. So yeah, we have access to different models. So maybe based on the provider, we can choose between the different models. But okay, so looks like we have installed all of our dependencies, and then we need to have an OpenAI key. So I mean, the good thing is that we it has support for different types of models. So not everyone might have access to a OpenAI credit. I do have, so I typically use OpenAI credit, and Google Colab has this feature where you can choose between the different LLM providers, and or I mean, it has this feature of adding secrets. So I already actively use like two different types of providers here, either Nebis or OpenAI. So I already had like saved credentials for that, so I don't have to manually right now expose my OpenAI key. But it's relatively simple. You just set up that. But if you are more concerned about using closed source models, then good thing is that you have support for local models with either Olama or Light LLM. So Olama is a very popular open source platform that allows you to run models locally. So in this case, we can see here that we are going to use the provider as Light LLM, and we would use an Olama based model. So Light LLM is also like a gateway service that allows you to access different types of LLMs, not just local models, but also cloud hosted models. So it helps you to route your request. So that is why instead of provider as OpenAI, you could also use Light LLM. So that is definitely supported. For this example, I guess, because I already have OpenAI credential, but I would imagine that the only change would be that you have to swap this OpenAI and very easily just use Light LLM and use your favorite appropriate model. So in this case, example could be like Olama, and you just change your model provider, and that's it. Because rest of everything is supposed to be the same. Because most of the other LLM providers are OpenAI compatible. So in fact, you can also like generally in GenAI applications wherever you're using OpenAI client, Python client, or your language client, you can very easily just like swap the base URL and provide your custom model name. So that's a good thing. So I think this should work well. I'll go back here and we will just go ahead and run this import statement. In the next thing that like what's happening is we are getting some data. So I would imagine like this is the data that we'll use to put into our vector database. So we have information about some of these coffee places, or maybe some random information around Seattle. And yeah, so that's the next thing that we're doing, which is like creating our vector store. So in this case, we are using ChromaDB, which is an open source vector database. So here, generally, what we do when we are creating a vector database, you start by um, creating the vector embeddings. In this case, we are using OpenAI embeddings, and then we are storing these embeddings with the original data in our vector database. So let's actually go ahead and run this. And once we have created the embeddings, then we would go ahead and populate our vector store. So that's what is being done here. And then RAG, as I mentioned earlier, that it's essentially the combination of the user query, performing the vector search, then enriching the retrieved context that we get after performing the vector search. So that response from the vector search is then sent as your input prompt to the LLM, and then we get the response. So here, but now I guess like this is where we are seeing. So what it says is that with this particular cell, we are getting the Trulens instrumentation. So this is where we are initializing the true session, and we get the and then we are also seeing a couple of other imports here, which are Trulens hotel instrumentation and Trulens span attributes. So just I guess for those folks who might not be completely aware of what spans at or what spans kind of correlate to within OpenTelemetry. So the idea is that what we are essentially doing here is, or at least what I can make out is that once we have created this Trulens session, because we saw in the guide here that we essentially create, I think we read it somewhere, that we create a database. Yeah, we connected to a database. So that is why we connected to a database where essentially each and every app call that we make, we are also going to create the spans. So the trace spans that we have, plus the input and outputs, because we want to like keep a track of all of the user inputs and all of the responses, and including the intermediate responses that we got, in order to truly understand whether our responses are accurate. Like that's one of the things that we have to keep in mind when it comes to LLMs, because you want to ensure that at each and every point in time, all of the responses are accurate. There is nothing that is probably hallucinating, because otherwise that can cause a ripple effect, and the subsequent responses might actually then be incorrect. So that is extremely important that you create like proper tracing. And then what we can see here is that in our class RAG, we have these Python decorators for instrumentation, and we are adding like specific attributes. So we have span attributes dot retrieval dot query text and span attributes dot retrieval dot retrieve context. So I would imagine that we will probably have more information in the instrumentation overview. So here we can do like tracing or tracking the entire execution flow. So yeah, I guess this is the main decorator. So we get this instrument decorator, which is a framework agnostic decorator. So that's great. And what specifically it does is it allows Trulens to log the function signature as span attributes. So this decorator, what it basically does is that it creates the traces span around the function. So generally, if you are using OpenTelemetry, you again wrap your entire function in a span. So based on that, in this case, like we are what we are probably going to do is that we are going to define semantic convention, because whenever we talk about OpenTelemetry, it's all about semantic conventions around the spans. So in this example that we have with RAG, what we are probably trying to do is we are trying to create a RAG span. So we'll basically like create spans for retrieval, for the generation part of RAG, for the query part of the RAG. So anything that is a core component of RAG, we would like to create like the spans for those, because what would essentially happen is that we could get custom attributes for, or we can create like custom traces for each and every part of, or each and every step of the RAG pipeline. So that's a good thing. So it gives us like a lot of flexibility, and then you can also instrument custom attributes. So if you want to add your own attributes which are not by default, that can also be done. So that's great. So that's a good knowledge to have, that this is primarily a custom decorator function that allows you to create your span attributes and get like relevant context. So but apart from that, like in terms of instrumentation, so the next function is like retrieving. So here, this is where we are doing the part of retrieval augmentation generation. So retrieval is actually performing the vector search. So here we are passing our query, we are getting like the top 4 results, and then we will use the most relevant results that we'll then pass. Then we have the generation of completion. So that is why we have the span type of generation. So we had span type of query here, the query text and the retrieve context. So that was the one that we were using here. And in terms of generation, you'll see that we are basically like joining the context here. So we join the context of the input query and the context list. So this context list is what we are getting from our vector search part. And then in the completion, you can see here that we uh, add the query, and we also add our context array. So that is what's basically happening here. So pretty straightforward in terms of RAG. And then we are doing one final instrumentation, which is for the response from. So this is the completion. So we get the completion. So that's good. So yeah, let's probably now run this part. And then we move to the feedback question. So I think this is the part where we have the evals. So let's also just explore what evals does. So I think this is a good one. So why do we need feedback functions? Measuring the performance of LLM apps is important. Ground truth is sparse. Um, and often entirely unavailable. So without ground truth, we can instead use feedback functions to compute metrics. Yeah, because this is like one of the core fundamental issues with LLMs, because there is so much of potential training data, and a lot of times we don't have like the proper training data on which these LLMs were trained upon, because that is never made public. So whereas in a traditional machine learning algorithm, you generally divide your data set into the training data set and the validation and the testing data set. So that gives you a lot of ground truth to cover. But with LLMs, that ground truth is not proactively available. So that's a valid concern. So feedback function, what it says is that it provides a programmatic method to generate evaluations on application run. This method of evaluation is far more useful than general benchmarks, which makes complete sense. And what it does is that it provides the feedback by combining more general models and made up of carefully constructed prompts and a custom logic to perform a particular evaluation task. So the construction is composable and extensible. Composable meaning that the user can choose to combine any feedback provider with any feedback implementation, and extensible meaning that the user can extend a feedback provider with custom feedback. Okay, so this goes probably a bit deep, but maybe we can jump back into our feedback here and explore that together. So what's happening here is that initially we are defining a groundness metric. So the idea is, I think, like what I was also like trying to say earlier is that groundness is essentially way where you try to say, and this is like just basic evals. Like if anyone is learning about evals, groundness essentially means that okay, are the answers claims supported by the retrieved context, because of course we are looking at a rag based answer. So it could be where you are trying to consider the answerability. Like if you're trying to ask a question and it has nothing to do with your grounded context, like relevant to your data set, then it probably makes sense to just ignore that. So that is the answerability. Like if the context doesn't have enough information, then the LLM should be cautious about giving you a response. It should think that if it doesn't have enough context, it should just simply ignore. So that is the groundness. So here what we're doing is we are getting our implementation. So this is the metric that we're defining, and it's coming from Trulens score. And I guess this metric should also be mentioned here. What do they mean by a metric? But I mean, it's just a simple metric in context of OpenTelemetry, I would imagine. But they are like talking about ground truth evaluation. So maybe we can also take a look at this. So this allows you to evaluate an app using ground truth. So ground truth evaluation is especially useful during early LLM experimentations when you have a small set of example queries. So this looks very, so this is like, I guess, very similar to your traditional machine learning experimentation, where you have your validation data set, which could be thought of as your ground truth, because you already have uh, exact replicas of like the response that should be there. So this probably is very helpful in that regard. So this is the groundness, and the ground truth in this case is coming from a set of example datasets or example queries which are that are critical to get right. So in this case, like when we say we are defining the groundness over here, we have the name groundness, and then we have a set of custom selectors. So in this case, we want to have the source, we have the statement, and the question. So these three are the ones. So basically source would be all of the retrieved chunks that we get from our vector search, and then statement is like the final output that we have, that we get as part of the LLM, and the question is the user's input query. So basically the grounded model, it will get the question, it will get the answer and the retrieved sources, and it will basically like return a groundedness score plus the reason behind that. So that's what basically it probably makes sense. And then next one, we have another eval, which is answer relevance, which is looking at the question and answer relevance between the question and the answer itself. So here, if you see, we have the implementation, and then the selectors are specifically the prompt. So the idea would be that does the answer actually address the question that we had asked? So we are evaluating that, which makes sense. And the third one that we have is context relevance between question and each and every context chunk. So here we are looking at again, the select context. So this was the retrieved set of context after performing the vector search and the original query. So what we are trying to say is, okay, for each and every retrieved chunk that we get, how relevant is it actually to the original question? Because if you see here, what we have done is that we gave collect list is equal to false. That means that this metric would run per chunk. And then one thing that we see uniquely over here in this example is this uh, aggregate. I would imagine that its aggregate is np.mean, which basically means that we are calculating the relevance score per chunk, and then we are calculating a mean. So what that means is that um, we could, because so this is one of the more niche things about trying to see whether there is a relevant answer or not, because you could technically have a grounded answer even if it has irrelevant additional context, because if the model focuses on the right chunk, then you would get the answer. But irrelevant context tends to generally increase hallucination risk. So that is like something to keep in mind, because even if there are certain chunks which are completely relevant, your model could just decide, okay, let me pick and choose the most appropriate one. But there could be scenarios where if you're probably trying to use like a different model architecture, it might pick up some other chunks. So it's important to keep that in mind, like choosing what are the most appropriate chunks that you're getting, because more unnecessary chunks can over populate the systems, and those are not depicting the like the actual result. So that's something to keep in mind, and that's why something like a context relevance is that much important. So I guess we can go ahead and run this if we haven't already. We'll run all of these feedback functions, and then we construct our, or we wrap our custom rack logic with our true app. So here, let's also take a look at what exactly is a true app, because I'm more curious about that. So maybe that should be there in our quick start guide and in the core concepts. So an app is the application that is tracked by Trulens, and it's the abstract definition of the tracking that belongs to the app. Okay, that makes sense. So you have run this, and then we can go ahead and run our app. So in True App, we pass our RAG based model, because we have created like a custom model here. And then what kind of feedbacks do we want? And then we'll use TrueRag as our context manager. And these are our test queries. Let's see what kind of response do we get. And apparently there is a dedicated dashboard that runs with Trulens, which we can explore. So here we are getting a leaderboard of the latency and the total cost. But let's also take a look at what is the dashboard. So we have results here in, okay, so we can analyze the results for Trulens, like the tracing and the agent spans. And if you want to look at the evaluation score or the tool call details, you could technically do that. So let's explore that. That looks pretty neat. Um, so let's explore this. It says that this dashboard is already running, which is a bit strange. Um, let's try to run this again. that's the IP address. It says that the is already running, which is a bit strange, but we'll just quickly take a look. It seem to be opening anything. Maybe we could restart everything again. Yeah, let's try to restart the session and run it again, just in case. It was a bit strange. But yeah, in the meantime, if there are any questions, would love to take a look. I guess I see a lot of questions, so we'll definitely take a look at those later. But this is like a really neat feature that we have with respect to Trulens, that it comes with all of this built-in observability and all these like different features, and hopefully we can take a look. But while that is running, we can see here the different types of evals that are supported. So we have like guardrails as well. So guardrails would allow you to block unsafe inputs from reaching the app, which is like again more relevant. Okay, so maybe in this case, like the secrets was not enabled. So we'll just try again. So now we are getting an error with OpenAI key. I hope it works. Let's just restart the session again. Sometimes it can cause an error. Like live demos are always a bit tricky, like especially when you're dealing with AI models. So let's just run this again. In the meantime, oh yeah, okay, so this should be supposed to be looking good. We'll populate our vector DB. Oh, I didn't add access. Okay, so this might run into an error again. Maybe ideally it's supposed to pick it up from the secret. So again, that is a bit strange. If I just like run this again, hopefully it picks it up this time. Otherwise, we could try to run this locally as well. Yeah, not quite sure why is it not picking up. Is the keys right here? Oh yeah, I mean the keys right there. Or maybe if I try to just can copy this and not show. Hopefully this works. Now I've added like the entire key, and that's a bit strange. Let's try to just run this locally. I'll have to copy this collab notebook. I can download this notebook locally and try to run this. In this case, let's go to the local repo. Oh, this will probably have too many changes. Okay. Let me do one thing. I'll just switch over this Python notebook to a folder. This is more relevant. Okay. Let me just go back. Then we probably have our quick start guide. So I can do a Jupyter notebook. We can try to just run this locally. Hopefully this works. So we'll try to run all of these kernels. Okay. So we did install Chroma. There's always an issue with having to work around with different. Now it just says no module named ChromaDB. So let's just probably try to like a pip install Chroma DB. For a second, it is working nicely. It's still, maybe what we can do is in the quick start guide, they had given us specifically like creating a virtual environment. So we can just try to populate that and try to use that with our app here. So I know that we are running out of time, but let's just try to do this again just in case. So I'll just create a new, this time I'll call it Trulens CNCF. Then we'll just do conda activate, and hopefully we can try to run the Jupyter notebook now in this environment. And run this again. Let's try to use the kernel. We'll just use the Python 3 kernel for now. Right. So it does say that all these dependencies are available. So hopefully it works this time. Okay. Always an issue with Python based approaches. Okay, that's fine. We can try to use, because ideally like what we like to do is run this in our environment, which like with the specific environment, but doesn't want to. We'll give it one last try with this. I have a feeling that this should work with the with this Google Colab. Let me just like refresh, or probably like just reopen this again in a new tab altogether. I'll just like go ahead, go back to the quick start guide, open it in a new Colab terminal, and hopefully it works. Let's connect. Environment is should be enabled. Disable and enable again. Remove these dependencies issues and install. But yeah, I mean, ideally, what we would see is like a dashboard that shows all of our spans. It shows up all of. Okay, this doesn't just want to. Maybe it could be an invalid key. Let me do one thing and like spin up a new OpenAI key that might be beneficial. Just like create a new OpenAI key on the fly. Maybe that could work. Okay, let me try this now. I'll, fingers crossed, I'll directly put this here. Oh, I just realized that the notebook access is not there. So, okay, one last final try. This time we'll make sure to enable the key. Or I thought that I had. Yeah, I mean, it's already enabled. That's a bit strange. Otherwise, I'll just give it a new API key and we'll see if it works. The first time it did work and it was able to load all of the data into ChromaDB, generate the embeddings. So that was a bit strange that it's acting up like this now. Okay, clearly not able to pick up this key. Let's see, hopefully this works. So we'll run this again. Okay. Not quite sure why is it not picking up, because now we are setting up our environment variable right here, and it's still not ready to pick this up. This is very strange, and we are running out of time, which is always interesting, because we would have loved to see the dashboard come up So generally you can also like run this as like a IPython notebook. Yeah, I'm not quite sure why doesn't seem to be picking up, but I know that we are like running out of time, but hopefully people get the understanding. But yeah, it's just like just a clear something wrong with being provided OpenAI key. Like I'm trying to create an brand new OpenAI key, but it just says invalid key, which is very strange. I tried to like set it up, but yeah, this doesn't want to work. Uh, Maybe so. If we have like probably last couple of minutes, we can give it one final try.
Yeah,
Let's
yeah,
at
for sure.
least, yeah, let's try to at least get the dashboard, because I mean that's what most people will be interested in, because you know, you to be able to like see the spans, and even I personally want to see, because I've not seen how that dashboard looks like. So perhaps one more thing that I can think of is we can download this as a dot IPython notebook, and we can what I can do is I'll close this Jupyter notebook. So we already have like Conda environment activated right now, and we will go ahead and just download these dependencies that we need for our, okay, so that's good. And I'll just do like export open AI API key. Oh, sorry. So I'll just do an export open AI API key, and let me just add the key myself. So give me like 1 second. So I'll just do export open AI API key. Okay, so having done that, let's move to the next part, which is I have downloaded this i.py file, and let me just move it over to our folder. So we should be back here now, and we should have it here, which is great. And let's try to run the Python 3 quick start py. So it says invalid. Oh yeah, actually, let's generate that fix. We'll just accept it with the help of AI. And let's try to run this again now. Let's try to fix this, and hopefully we can just remove, I think that we can just comment that out. And we'll just accept it. Then we can start to actually run it. So let's go ahead and run the app now. Let's give it one final try. Hopefully this time it works. We have set our environment as well. And maybe in the meantime, we can start to answer some of the questions. So we had like a
I think that there
question.
is only one question that's summarizing one. No, two questions that's summarizing one. I think from if we are evaluating LLMs, and the other one if evaluates LLMs. Yeah, from
Yeah, I
view.
mean, when you are evaluating the LLM response, that gives you, okay, because sometimes what happens is that if your chunks are not being created appropriately, in those scenarios, we might run into, because sometimes your vector search, when you're performing the vector search, when you're creating the embeddings, maybe those embeddings are not the most accurate, right? Because you could fine tune an embedding model and get much better embeddings, because if your embeddings are not optimized during that time, you might get much low scores, right? So when you're doing a vector match, you get a score where you're finding like the cosine similarity between your input query vector and the vectors that are already there in your database. So if your overall accuracy, the score, if you're ranking it between 0 to 1, if it is less than 0.5, which means that the retrieve context do not match your query at all, so that's a good indicator for us that, hey, perhaps your vector search results or the chunks that you're creating are actually not helpful. So when you're performing the RAG and you're looking at all these like groundedness metrics, or you're looking at the retrieve context metrics, how relevant those are to the input question, these are extremely important for us. So yes, so Vyom, like, he makes a very good point that even after RAG, if you want to make our responses, RAG responses, much better, we want to look at how relevant the retrieved context are, because it's not 100% accurate, or it's not 100% the case every time that your retrieve context might always be relevant enough. You might get retrieve context, but whether they are relevant enough or not is something that you have to track very closely. So that's like one thing to keep in mind. Okay, so good thing is that we can see our Streamlit URL, and hopefully this shows up. So, oh, perfect. So we see our, oh, nice. So after like trying out Google Colab and Jupyter Notebook, a simple Python file works best. So here you can see the app versions, and you can see the relevance context and also the context relevance. So it's about 83%. And if we take a look at the records here, you can see the groundedness, the answer relevance. So these are our evals that we have run. And then we could take a look at our two records. So we can see the exact cost and the total token utilization. So this also gives you, this is another good thing, that you can also take a look at dedicated understanding of your total amount of latency and the input cost associated with evals, running your evals, because the most important thing about productionization is you want to take a look at what is your latency and input output token utilization and the cost associated with that. So that's a good thing that we have um, that built into our app. And it also like just gives you filters if you want to like add or remove something. So that's good. So we can add or examine. We can also like examine the records as well if required. So if you want to examine, these are the two different, and so that's a good thing that we can. Oh, and then this the trace details. So here we can see what was the output, what was the input, and we can take a look at the exact trace. So this is the entire timeline of the trace, the exact trace. So first we had the query, then we retrieved it, then we generated the completion, and then we had like the evals run for each one of them. So we had the three specific evals that we ran for this particular trace. So that's a good thing that we get all of these capabilities as part of this Trulens dashboard, which is a Streamlit dashboard. So I know that we are out of time, but next things that you could do is you can also add like your own custom guardrails. And if you look at streaming apps, you can also try to evaluate streaming. So if you're like sending chunk by chunk rather than waiting for the LLM to generate the complete response, you can also do that. So that's very interesting. But I think for someone who comes from an open telemetry background, the most interesting aspect is that there is like built-in integration with open telemetry, which is very relevant. And I would like to personally like spend a lot of time going through like the different use cases, whether it's like for PI detection or evaluating the different results with the help of Trulens. But yeah, overall, I feel like it's a very strong platform, because I have previously like used Open LLMetry, which is also another open source platform, but that like focuses more on the tracing part. But having like built-in support for evals and tracing is something which is like very unique, which I learned today from Trulens. But yeah, hopefully this was relevant for people and they understood like the main difference between tracing, which kind of looks at okay, how much token utilization you did. So that is why this example that we saw here, with tracing, you can take a look at the exact record of how everything, stepwise what's actually happening. But then evals basically give you okay, is the response actually accurate enough or not. So evals help you to understand the quality of the responses, and then tracing is like you understand okay, what's going on behind the scenes. You understand about how much total tokens, how much total cost is being associated, how much latencies you're getting, and you can trace each and every step and understand like what happened there. Because since there are so many steps, something could go wrong at any one particular step. maybe in your RAG pipeline, retrieval is great, but then maybe your input prompt for your generation of completion is not that good enough. So that way you can trace both, and that's how you can like get a clear picture of your agentic applications in production. And I saw that there is another question, Sergio, which is
I think that there is another one about MCP, but because of time,
MCP
maybe the
performance.
people can, yeah, maybe people can contact you, maybe.
Yeah, I
Mhm.
think there is like a
Mhm.
couple of them. So
Uh-huh.
if I'm not mistaken, in fact, like I'm not sure if Trulens has support for MCP performance as well. But see, ideally, like what MCP is, right? MCP is also a bunch of tool calls. So when you add an MCP server, because today, like most agent frameworks natively support MCP tool calls. So you could also probably run or create like a custom span events for your MCP tool calls and then evaluate those. So I think like that should be pretty straightforward.
For sure. So I think that it's time, right? So if you
Yeah.
want to, well, you can join or contact Shivay. He works a lot on this kind of stuff, AI, LLM, and you are expert on that topic. So maybe you can contact him. And I think that we are closing right now. So thanks everyone for joining this latest episode of Chat Look Back Off. You can participate in this way as a CNCF ambassador. There are a lot of kind of shows that you can join and learn a lot about Cloud Native. So thanks for joining us today, and we hope to see you again soon for the next episode of Chat Look Back Off. And I want to say goodbye from Guatemala and Shivai.
Yeah. Goodbye from India.